Cool. Thank you so much, Rian. Thank you everyone for joining this session for today. My name is Joshua Khoza. Currently, I'm a cloud architect. I enjoy spending time with my family. I enjoy working on AWS Cloud. I've been working on cloud since 2018, and I've been working with multiple different cloud providers, be it Azure, AWS, Google for that matter. So the one that I enjoyed the most was, it obviously started as a company thing that the company wanted to become a partner with AWS. And then it became something, it became a hobby to myself. Then I started becoming an AWS community builder, assisting people, even though I'm not familiar, I'm not that well known within the market. I do assist people on the background. I'm just one of the guys that actually stay in the background while other people are actually shining. So I took it upon myself to say, you know what, maybe it's my time that I should actually come out of the closet and do public speaking. So a disclaimer there, please bear with me if I'm a bit shaky. Just understand that this is my first time, and I would like to share whatever that I can share within this presentation with you guys, so that we can actually all share the knowledge and use tomorrow's tools to build Africa, for instance. Thank you. Cool. Today I'm going to take you through getting started with Amazon or AWS EC2 Auto Scaling. This is one of the services that is highly utilized when it comes to managing EC2 or doing capacity management for different applications and so on. So I'm just going to go to the next slide. Okay. Just give me a moment. If I can get the page, cool. Yeah, so the agenda for today, we're gonna look at to understand what is auto-scaling in general, because I believe that auto-scaling plays a big part not only in EC2, but it actually plays a big part in other different compute resources within the Amazon space. And then from there, we're gonna talk about why AWS auto-scaling, and then we're gonna look at why the, we're going to look at the benefits of auto-scaling, and then we're going to then look into the specific focus, like I mentioned, getting started into AWS EC2 auto-scaling, and then the types of scalings that we can actually get within EC2 auto-scaling, because it's actually a powerful service. And from there, we're going to look at a live demo, provided that the demo gods allow us. We're then going to look at that. Right, and then I'll just go to the next screen. So in general, what is auto-scaling? So auto-scaling is a service that allows you to manage application capacity and automatically adjust capacity with to maintain steady and predictable performance at lowest cost. So it will look at maintaining capacity for your specific application based on usage. For instance, let's say, for instance, you can then define specific metrics to say you want your capacity to be this much to run your application, for instance. For instance, auto scaling, it actually has a centralized console or interface that allows you to manage auto scaling for multiple resources and multiple services within minutes. So if you look at the pointer that I actually put there, you can enable it for EC2 in EC2 instances and spot fleet. Spot fleets is when you want to purchase sort of like discounted EC2 instances that can then process do any job processing for you at a discounted price. And then it can also work with ECS tasks. If you look at, for instance, if you're building a container services, or the back-end resources that can then be managed by Autoscaling on your behalf, rather than you managing that or adding capacity on the back end manually. When it comes to DynamoDB tables and indexes as well, so the NoSQL database that can be managed by Autoscaling itself as a service on the back end. And then when it comes to Amazon Aurora, is one of the well-known database services that is provided by Amazon, specifically provided by Amazon. So those are the kind of services that are actually supported under Autoscaling at the moment. It actually provides, it's a service that actually provides recommendations that allow you to optimize performance, cost, and balance between that. So you can create custom metrics to balance between cost and performance and those kind of things. So if there's any questions, just put it on the chat, and then, or we can wait until the last, until the end of the presentation, then we can look at that. So the Autoscaling in general it can be a standalone service that can then be used to auto-scale or manage capacity between these different types of services, whether it's EC2, ECS, DynamoDB, Amazon Aurora, and so on. Right. Why AWS Auto Scaling? To me, when I put this presentation together, I wanted to put a story behind it to say the challenge that we have in terms of high availability on-prem, it comes as a reactive and manual thing that, let's say, for instance, if your capacity is fully utilized and you want to add more resources, you then have to think around those lead times to say, what are the lead times for me to add more capacity or have servers deployed or a bot deployed, rack and stack, for instance, or then the administrator then installing software and those kind of things. So those are the kind of things that you actually face as a challenge actually on-prem when it comes to high availability and resiliency when it comes to your applications. So if you look at the second screen, you actually require administrators to come and rack and stack and then deploy softwares and those kind of things. It then takes a long time or lead time in order for you to have those resources deployed within your environment to maintain capacity for those specific for your applications on-prem, for instance. It's a reactive and manual approach that we then follow when we are on-prem. But when it comes to AWS, for instance, they made it a little bit easier for us to add capacity when we need it and remove capacity when we don't actually need it, for instance. So the benefits of auto-scaling is actually eliminates the need to respond manually in real time to traffic spikes, for instance. So and then when it comes to fault tolerance, it actually provides better fault tolerance because it goes and maintains to say if it happens that your EC2 instance is unhealthy, it will then go in and replace it for you to ensure that it actually maintains fault tolerance within your auto scaling group, for instance. So it's going to replace it by launching a new instance from an AMI. So we're going to discuss that so that you can have an idea what an AMI is. And then for better availability, for instance, so in order for you to ensure the application is always has the right amount of capacity to handle the current traffic or current traffic demand that you have on your specific application. And then at the end, it also has better cost management. So you only pay for what you use at that specific time. Say, for instance, if you need five number of servers deployed that is handling your application at that specific time, you will only pay for those specific resources at that time. Autoscaling itself is a free service. You only pay for the resources that are actually running, like your EC2 instances. So it's a service that does capacity management on your behalf. So you can either do that manually, or you can do that automatically using different metrics. Okay. So the conversation of the day is obviously talking about Amazon EC2 Auto Scaling, right? So like I mentioned, this helps you maintain the number of instances. So it will help you maintain the number of EC2 instances that are deployed in the auto scaling group for your specific web application, for instance. So when it comes to the illustration image that I actually put there, when it comes to auto scaling, you can define the minimum size, the desired capacity. So the minimum size, it's a threshold to say it cannot go below 1, for instance. And then the desired capacity, that's the desired, so that's the capacity that you want your auto scaling to start with, for instance. So we'll look at those kind of things, what is the difference between the minimum and desired capacity when we do the demo, so that you can see the difference between the two. So the desired capacity is when you want when you first deploy your auto scaling. So it's going to deploy with the desired number of capacity. For instance, here we're looking at two instances that are actually desired to maintain your application. So by using different metrics, it can go to 1. But when you deploy, initially it will have your desired capacity. If it's 3, it's going to have 3. If it's 2, it's going to have 2. So you can maintain that. And then there's maximum size. That's the maximum threshold to say it cannot go above that. So if your instance, if your application then is sieged or attacked, for instance, it can only go up to so far. It can only go up to that 4, for instance. So that's, we look at things that we're saying we don't want it to obviously not be a cost conscious, for instance. So it enables you to have a cost-effective architecture that provides the best customer experience while minimizing expenses. So that minimum and maximum, for instance. Okay, I'm going to try and move quickly because I think we might run out of time for the demo as well. So the type of scaling, there is one which the first one is which is a manual scaling. So that's when you go in on the console, clicky, we update the auto scaling group to increase the capacity. So you start with your desired capacity. Let's say, for instance, it's 2, and you see that tomorrow, for instance, this application will be hammered. So you can go and add capacity manually, changing the auto scaling group on the console itself. And then there's schedule scaling. So you can have, let's say, for instance, like I mentioned earlier, you would know, let's say, for instance, if you look at like Black Friday, for instance, because there are other customers that have auto scaling deployed to say, if it happens that it's going to be Black Friday tomorrow, they will want their instances pre-warmed, already ready. So sometimes you want to increase based on demand. When demand grows, you want to add your capacity, but some of customers want to implement, you want to scale on a schedule to say, maybe Monday morning, I want it to scale up, for instance, and then maybe Tuesday morning, because I know there won't be any traffic, I want it to scale back down. So it scale based on, you set schedules there. And when it comes to dynamic scaling, that's when you monitor different metrics inside your environment to say, let's monitor maybe in your CPU utilizations on the overall instances that are actually part of the auto scaling group, or you can look at different metrics, let's say your memory metrics on your on your environment or your auto scaling group or your instances. And you can also create custom metrics that you can trigger to invoke that scaling process when it comes to dynamic scaling. So it will monitor different types of metrics, and then it will scale based on that. And then predictive scaling, I actually had to put this picture here, for instance. So predictive scaling, it goes back in time to look at the history of what was happening previously. And based on that, it would say, let's say on a Sunday, it was not that bad. So it's gonna increase and leave it to that minimum. And if you look at Wednesday, for instance, it had the highest number of EC2 or capacity that was required. So it's going to look at back in time to say, oh, last Wednesday, we had a lot of users on the system. So, or requests coming through to the system. So what we're going to do, we're going to follow the same process of what happened last week. We're going to implement, we're going to scale based on those predictions, right? And we're going to move to the next one. Okay, that was quick. I think, let's just see. Okay, just give me a sec. Cool. I think that's there. And then we're going to jump onto the live demo. Maybe just to give you a context, because before I jump into the demo, I want to, because this demo deploys a lot of resources on the back end, I just wanted to bring up the console so that I can show you a little bit pieces of the auto scaling itself, rather than showing you the EC2 auto scaling alone. I want to show you the, let's see, auto scaling as a service. So you can go to the console and search for auto scaling. So it's a standalone service that actually manage capacity for you for different services. So if you look at these are the types of, these are the services that you can actually manage using auto scaling. You can go get started. You can, let's say, look at your different stacks. You can search your resources by tags, for instance, to say these are the types of resources that I want to scale, and then you can then manage your EC2 auto scaling. At the moment, it's not there. I'm going to deploy it so that we can actually look at the features that it actually gives you. So in terms of our live demo, right? Because I think having something on there will actually make a little bit sense of what is happening when it comes to auto scaling itself. So our demo is going to be automated. We're going to be provisioning, it's using Terraform, because there's a small app that I went and put together for this specific demo. The essence of auto scaling group, or the attributes that, or the components that you need in order to have auto scaling manage capacity on your behalf, you need to have a launch template. I'm going to go to the console and show you where the launch template is. Your EC2 instances with your auto scaling group. So your EC2 instances will be deployed from the launch template, and then will be chucked into the auto scaling group itself. From there, it's going to create the application load balancer, which then will point to the target group, which is also part of the auto scaling group. We're going to create also an instance profile that then can be associated with those EC2 instances to pull the application, because the application is actually currently stored in S3. And then Cloudwatch alarms, I'm going to be using that for that auto scaling. I'm going to be using CPU metrics, which is called targeted scaling, which is we need to maintain a specific threshold or percentage of CPU within our auto scaling. For instance, If we're saying we want to maintain 50% CPU utilization within the auto scaling group, we're going to maintain that. That's target scaling. I'm going to show you that on the console as well. Then we're going to verify all resources and see if it's serving traffic. And then we're going to perform a stress test. And then we're going to terminate an instance in the auto scaling group just to see that functionality as well. Right?
Joshua, we have a raised hand from Najubulu. I'm sorry if I mispronounced your name, but do you mind asking a question? I'm unmuting myself.
Yeah, no, that's fine. So Josh, the launch template. Can you maybe just explain to me again what it is? Is it like another EC2 instance, or what is it really? And maybe distinguish between the launch template and the instance profile.
Okay, no worries. I can actually elaborate on that. So the launch template is, let's say, your attributes of what your instances will look like. For instance, maybe let me just go to the console so that we can have a view of what it is. So a launch template. So let's say, for instance, if you create a launch template, this is where you define your instance type, your AMI, your template, for instance, to say this is the image that I want my EC2 instances to provision from, for instance. So if you look at when you provision an EC2 instances, for instance, you go and select an AMI, right? You select an AMI, you select an instance type, you select a security group. It's either you add volumes if you have to add volumes. So a launch template, so rather than you deploying an EC2 instance and putting it into an auto scaling group, a launch template is a combination of all of those attributes which are then pulled together by the auto scaling group to deploy automatically for you. That's the launch template.
Oh, okay. Now I see it. So instead of you deploying the AMI and then doing configurations, you yes. do configurations of the whole entire environment, yes. Including the EC2.
Yes. So here you would say, okay, I'll say PTA meet up template. So template, for instance, and then you can also give it a version if you want. And then this is where then you come in and select your AMI. So remember, EC2 instances have to be created from a specific image, for instance. So you can go and browse to say, okay, this is a type of image that I'm looking for. Is that I'm looking for an Amazon Linux, a Red Hat image, or SUSE or Ubuntu, for instance. You select that image, right? Okay, so that one might not be available. Let's just see. Let's just go there. Let's just select the first one there. You select your AMI. There's your AMI there. It's selected. Then you select your instance type. So which instance types do you want your auto scaling to provision, right? For instance, I'm going to select T2 micro, and then now you need to select your key pair, for instance, the one that you want. So let's say, for instance, if it happens that your auto scaling scales and your application is not deployed correctly, you would want to log in there and check why it's not deployed correctly, because this thing is going to automate the entire process, right? We don't want to interfere, or we don't want to log in and deploy the application. This is going to automatically deploy the EC2 instance, and then it's going to automatically deploy the application itself as well. So you then select the key that you want, because obviously when you create an EC2 instance, you want the key. And then you select where you want, which subnet you want the EC2 instance to be provisioned. You select the security group that you want for these instances to be deployed on. Then you can attach more volumes if you want, but by default, the AMI comes with the 8 gigs volumes. You can change the type of the the volume type. And then under advanced, for instance, this is where for instance, you put in your user data. Let's say, for instance, in my example, right? So if we look at my example, I don't want to confuse everyone, but for example, this would be your user data, for instance. So your user data would be the predefined software that you want to deploy within your EC2 instance to bring up the application. So for instance, I would do apt-get update, which is updating the security patches of the operating system, which is in this instance would be Ubuntu. And then I would be, for instance, for the application that I will be deploying, I would need to install stress test, this stress tool in order to perform the stress test to show you the auto scaling stuff. And these are the other softwares that I need for the application to actually come up. I need AWS CLI. So these would be some of the pre-warm-up tools that you want to install on your application, for instance. So these would be what you want to add there. So those would be when the auto scaling spins up that EC2 instance, those would be under your user data, will then be executed on the server, and then the server would spin up with those applications already there installed. So
okay,
that's your template for instance.
And the instance profile. Sorry, just quickly on the instance profile.
Yeah, so the instance profile is more of sort of like permissions or policies that you actually give your EC2 instance to access other AWS services. Let's say, for instance, if you want to give it access to S3 or access to RDS, for instance, relational database services. So in order for it to call those other services or access resources within those services, you would then assign an instance profile, a profile to that instance in order to give it permissions to access. So we'll look at that as well.
Okay, cool. Thank you.
Okay. Any other questions?
Joshua, there is one or two, but I think maybe if you can start with the demo and then we can leave some of those for the end, just for the sake of time.
So I've already prepared the demo, right? I'm just gonna start. I'm just gonna deploy it because it's gonna take some time, and then I'm gonna. It's gonna take like 5 minutes to bring up all the resources, but just to give you like an idea of what is gonna what this demo is gonna deploy. From this perspective is the first things first is gonna deploy. We know we need the structure, which is the VPC, which is the networking structure that we require the resources to be deployed in. So it's gonna deploy. Maybe I should actually bring up the architecture first to give you an idea. Okay, can I bring up the architecture? Let's just see. Just bring up the architecture first. Okay, let's just bring up the architecture. So what we understand as AWS, I would say, for instance, just assume, let's say, for instance, the outer square box is the AWS Cloud. So you log into the console, that's the AWS Cloud. Then you go and select the region. You go to select the region. For instance, I said EU West 1 here, but I'm actually deploying it EU East 1, for instance. So that would be that you then select your region, and then within your region, there's what we call availability zones. These are your availability zones. You deploy within your availability zone. So from there, we then deploy subnets. In this instance, we've got 2 public subnets, and then we've got 2 private subnets. And then we've got the internet gateway, which allows you to break out of your VPC. This here, the green part is your VPC, allows you to break out. The internet gateway allows you to break out of your VPC. Then we've got your application load balancer. We've got your auto scaling group in the orange part. And then we've got your two T3 instances. And then at the bottom there, we've got your RDS, your Amazon Relational Database Service. And then on the right-hand side, we've got S3, which we've got our application deployed to. We're going to be pulling that using that user data. We're going to be using Cloudwatch. Cloudwatch is we're going to be using for Cloudwatch metrics that's going to be monitoring the auto-scaling group or instances in the auto-scaling group to say if the capacity, 50% capacity is reached, then add more instances. If it's below that, then remove instances. So capacity management, for instance. And then the IAM is where we obviously going to be creating the IAM, the IAM policies and the instance profile in order to integrating with IAM role in order to assign that to the EC2 instances that will then be used to access S3. So this is where that instance profile comes in. So that's the architecture for the day. So once everything is deployed, the users can then be able to access the URL of the load balancer. That net traffic would be round robin between these two instances. And then we're going to kill instances and see auto scaling in action, right? If I bring up the architecture, like I mentioned, we're going to be deploying the VPC. We're going to be deploying, I'm not going to go into the code itself because it's going to derail us a little bit. But we can have another session, another day, and then look at Terraform and how we can build resources on AWS using Terraform. So it's going to be building an application load balancer. It's going to be building an auto scaling group. This is the assumed role for that instance profile. It's going to create a auto scaling group policy. This is our auto scaling group policy. It's going to be based on CPU. This is the alarm for the CPU for the scale out. I should have actually mentioned the scale out. And this is the auto scaling policy for the scale down. And this is the alarm for scaling down. So for instance, for scale out, we'll say if they say, for instance, the EC2 instances that are deployed, if they have, if the threshold is above 20% for your CPU for a period of 60 seconds, with a evaluation of one data point. So I'll show you this on the console as well so that you can see. Then scale up. So it will add capacity. And then the scale down is it will look at the threshold of 17%. So if the CPU is below 17%, then we'll remove minus an instance at a time. So that's the user data of the application. This is the security group of the web servers that are going to be deployed as part of the auto scaling group. And the IAM role, this is where we create that EC2 policy for that S3 access. So the policy is in this. This is the policy here. We're saying we want it to access all S3 and then some of the RDS, because the application itself that we are deploying is going to be calling an API and ingesting the response that it gets from that specific API into RDS, for instance. And this is the key for the EC2 instances. And then from there, this is the RDS instance that's going to be deployed on the back end for the application. So if you look at auto scaling itself, you want to create an application that allows for auto scaling, for instance. So it's a decoupled application that allows you to scale the front end while the back end is also intact. And when you look at Amazon Aurora, that's when you come in with the auto scaling to say, I want to scale the back end, which is Amazon Aurora. And then you can add more capacity for the back end as well. And then the rest is just the variables that I used for the application itself.
Can I ask you a question before you move on this?
Sure. Let's clear.
So the basic question I have is, let's say I'm not familiar with Terraform, but I'm comfortable or confident working on the console now.
Yes.
Is there any way that I can maybe do something on a console and then get the Terraform script of what has been done, or do I need to write the script from scratch all the time?
So I had reviewed a few tools back then, but they weren't that very good when it comes to converting infrastructure or pulling infrastructure that is already deployed, for instance. I mean, what Terraform can do, right? There's just a few limitations within the environment. So you can deploy resources and then be able to import them using Terraform. For instance, you can import resources that are already deployed in the console using Terraform, and then reference those resources within your Terraform. So you won't have a specific tool that will go and say, I will go deploy everything using the console and then want to export that. Right? At this current moment, we did a little bit of digging. At this current moment, I haven't seen any tool that can do that at the moment. No, unless anyone else in the call has seen or have any other views.
No, it's fine. I think you can continue.
Okay, cool. Hopefully there's our under 4 minutes 57 seconds. Those are 40 resources deployed under 4 minutes. That's a power of Terraform, right? Very quick. So under outputs, I've got some resources that are configured Terraform to output there, which is your RDS endpoint and also your DNS name for the load balancer. So I'm just going to copy that, right? I'm just going to copy that, and then I'm going to open it. Everything is working. There we go. So this is the simple website that I went and deployed. So essentially, just to make sure that this is serving traffic from the correct instances. Like for instance, we see this one is hosted in AZ/US1B, and this is the instance name, just to show you. So here at the bottom here is just an API. Maybe I can just also show, I can also bring up that, I don't want to bombard you with code and those kind of things, but just to give you a context of what is happening here. Let's just go index. So essentially what the code is doing here, it's actually killing the metadata on the EC2 instance itself. It's going to pull the availability zone. That's what we are seeing there. And then this one is pulling the instance ID. And then we're just echoing that onto the page, right? And then this here is just doing that API call. It's just calling that API call, which generates latest 10 corporate jargons, and then taking those and ingesting that stuff into it's actually writing each and every line into the database, into our RDS. So that's the database there, the password, the user of the database, the password, there's the database there. That's the simple side of the application.
Sure.
So yeah.
Can you share that link for us in the chat? And we can all read it as well. And,
okay, cool.
See for ourselves what instance we get.
Okay. No,
and I've never heard of that website, corporate PAs.
Yeah.
Look that up now.
I'm gonna put it on the chat there. So yeah, so 10 corporate jargons at a time. So every time you refresh the page, it's gonna hit that API, pull 10 corporate jargons and ingest those and write those into the database. So if you look at, I mean, I tried to even put a different picture for each and every availability zone. Let's see. So if you see now, it's saying AZ1 with a different instance ID. So at the moment, if we go to, for instance, on EC2, okay, so it's actually auto scaled. Okay, let's just do, okay, let's just go to, let's start with the template. I just want to show you the template that we were talking about. So this is the launch template. So your launch template will obviously have the attributes or the details around the EC2 instances that are going to be deployed. There's your AMI that's going to be used to deploy as part of your EC2 instance. There's the instance type. There's the key that will be associated. And then there's the security group. And then under networking, under details, there's your metadata or user data that's going to be deployed. So your EC2 instance will go into like a pre-warm-up stage before it can then be part of an auto scaling group. It has to install all of these. I'll show you that the timer that it has to wait before it can actually join the auto scaling group to deploy all or to execute all of these of this script here. So that's your template. From there, that's your template. From there, we're gonna go under auto scaling. Let's go to auto scaling. Create auto scaling groups. So there's the auto scaling group. I see it actually went in auto scale. So I'm not sure why it went to 4, but we're gonna check now. So this is your auto scaling here. So it actually went and created the auto scaling. At the moment, it created it with the desired capacity of 4, minimum capacity of 1, maximum capacity of 4. So like I mentioned, cost conscious, it's gonna go and maintain these thresholds. So desired capacity of 4, it's just saying that I'm gonna start the initial auto scaling with 4 instances. And then I'm not gonna go below 1, right? And I'm not gonna go past 4, the maximum of 4. Then this is where it's referencing that launch template. That launch template is bringing all of those attributes into this. This is actually defined inside the Terraform that we actually went and deployed. Then from there, we went and created the load balancer and the load balancer. So this is the load balancer. This is where it actually pulled that name to present to us on PowerShell. And then this is the URL. Now I was wondering why this thing was auto scaling. It's because everyone is actually hitting the URL. Beg your pardon. So if you click that, I thought I was going to actually stress test it myself. So you actually stress tested it for me, guys. So if you click that, you will see it's switching. Now it's pay. It's using this instance, which ends with 0. So it's gonna actually round robin between these instances. So if you look at this, it's gonna round robin between all of these instances. So it's gonna be in AZ1, AZ1A, AZ1B, AZ1A, AZ1B. And every time I call the URL, it's gonna write a line. As you can see, it's increasing. So every time you call it, it's writing a line into the database. So, I mean, I'm not gonna stress test it now because everyone already is already on a maximum of 4, right? So the one thing that I can do is I can go and terminate, right? Remember what we said. We can either, based on health checks, if let's say, for instance, let's go to the load balancer, right? First, and I'll give you an example. So there's the load balancer. This will be your listener. It's port 80 for now, but you can obviously add HTTPS on there. You put your certificate to be a secure site. This is going to load balance the traffic across all the EC2 instances that are actually currently deployed on your auto scaling group, right? From there, they are all looking at the same database. So each and in any instance that is deployed on that auto scaling group is looking at the same database. So if you look at the target group, your target group is where your instances are currently running as target for your application. So there's a difference between the target group and the auto scaling group. The target group is used by the application load balancer, or the load balancer for that matter, to distribute traffic towards this group. At the moment, there's 3 instances, right? I see the traffic is going down, so it's going down. So there's only 3 instances at the moment. So every time you hit the load balancer will round robin across this. So the auto scaling is a different thing altogether compared to the target group, right? The auto scaling group maintains this capacity to say, if this fails a health check, right, I'm going to redeploy a new one from the launch template, right? So that's the auto scaling part of it. So if, let's say, for instance, I go, so it's terminating because the traffic is probably dropping now. So if I go, for instance, and terminate an instance, right, it will maintain that capacity because that's my desired capacity at that moment. So this is now that auto scaling kicking in. It's going to scale up based on the minimum or max, the capacity or threshold that I went and defined. And that threshold, let me just go here. And auto scaling, I'll show you the threshold where the threshold is defined. So I'll go to auto scaling, automatic scaling. So this one currently at the moment it's using that dynamic scaling. So using metrics to monitor if it's above or equals to 20 for one consecutive period of 60 seconds. If that metric register that it's above or equals to that, then it's going to add one capacity unit, which is one EC2 instance, right? And there's that time wait period, right? It's going to wait for 100 seconds before allowing another scaling activity, for instance. So it's going to add this capacity unit and it's going to monitor to say, is it still above or equals to 20 for another one consecutive. I had to put this together so that I can show you the auto scaling happens, right? But you can always play around with these numbers to make sure that it suits your application. And it will carry on adding until it reaches that maximum capacity that you define. So when it comes to scaling down, it's going to say, I'm going to look at CPU utilization. Is it equal or less than 17% for one consecutive period of 60 seconds? If it's below that threshold, it's going to remove one capacity unit. That's the metric to remove capacity. So those metrics are here. So if you look at this, for instance, the scale down is triggered, right? So the scale up, we look at the scale up when it went up, when everyone jumped onto the site and logged on, it triggered this metric here. The threshold is sitting here under 20, right? So it went above that. When it went up there, it then added more capacity to maintain that maximum capacity that I defined on the auto scaling group, right? And then when it went below that, it said 17. It's going to look at that and say, oh, it's below that 17 threshold mark. So I'm just going to start now removing instances. Right? So that's exactly what this thing is doing here. So another way where you can see this happening is here. So when I launched it with 2 only, and everyone started jumping onto the URL. It went and added another 2, right? It added another 2, and we had that maximum of 4, all of them. So it's going to keep it at that. As you can see here, it goes and say, so these were the ones that I launched, from 0 to 2. These are the ones that I launched, and these 2, it said, now the desired capacity is changing because the alarm has been triggered. The CPU alarm in state has been triggered. Now I'm increasing the capacity to 2. And that 1 minute or 60-second threshold or 1 data point was still active. The alarm was triggered again, and then it added another one and maintained that 4 capacity units or instances. Then when it saw that now it's below that 17 threshold mark, it went and triggered the other one to remove, start terminating, and still maintains those 2. Right? Okay. I think that should be it from my side, unless there's something else that I didn't show. So one thing that I didn't actually, I wanted to show was auto scaling in general. Like I mentioned, auto scaling is another, is actually the actual service that you can use to configure different scaling plans for different resources. For instance, this will automatically detect, right, some of your services or resources that can be auto-scaled. For instance, if we look at this, it's going to look at that. Now it's picking up that there is a auto-scaling that we went and deployed. We can then create a plan out of this to say, okay, we can look at different scaling strategies. It can optimize for availability. So this will make sure, based on the CPU utilizations, to make sure that it maintains availability for your applications. And then here it's going to balance between availability and cost. For instance, here it's going to optimize for cost. It's going to say, I will rather keep 1 instance for now until I'm sure that I can add another instance to maintain cost. So it might sit up to, it might wait until it reaches 70%. But if you look at balance of availability and cost, it balances, it says 50% cost, 50% utilization. But for optimization, it's going to say no. For optimize for availability, it's going to say no. As soon as possible, I will make sure that I'll add capacity to make sure that your application is available. From there, then you can go and say whatever that you want in terms of your custom metrics, to say, I want to do my own custom metrics. I want 60%. I want to maintain 60% of average CPU utilization on my environment. So then it's gonna scale based on those custom metrics that you went and configured there. Cool. I think that should be the end of this demo, unless there's any questions.
That was very cool. Thank you, Joshua.
No worries, thank you.
Yeah, so let's open the floor for some general Q&A questions. If you have some, please unmute yourself and you can just ask your question. And while you do that, you can fill in that bit.ly link that I shared in the chat. Like, completing that is your entry into the lucky draw that we're going to do in a few minutes for 2 AWS $25 credits. So please fill that out for us. And yes, then let's hear some questions. People are usually shy. Let me see what we have in the chat. So we have one that asked, I know we are talking about EC2, but I would like to get some advice on how budget alerts work, because I set up an alert and had stopped my instance. I don't think the alert can stop your instance, not automatically. Okay, so to avoid incurring cost, but still got charged. Do you know perhaps why? Joshua, do you want to answer this or?
No, I can take it. I mean, it's a cost optimization question. So budget alerts are just there to keep you, or just to let you know that you are utilizing more than what you budgeted for. That's your threshold that you obviously set on there. But then, like you mentioned, it's not there to say, I'm going to delete your EC2 instances or your resources, for instance. It's just there to alert you to say, no, you just went above the threshold that you set in terms of your cost, for instance. Let's say, for instance, you don't want to go above $70 in a month. You just say, you just set that threshold or budget alert to say, I don't want to, just to keep you, because remember, when it comes to the environment like Amazon, you pay for every resource that you deploy there. So some of the resources you might go and deploy and you forget about them, right? So if, let's say, for instance, you've got your budget alerts configured, it can give you an idea to say, I think there is a service that's running elsewhere that's chowing my money, for instance. So that's the little I can say around budget alerts.
Yeah, so it's mainly informative. Like it won't shut down anything for you.
No, yeah, no.
Unfortunately. We have another question that asks, can we attach an IAM role from launch template?
From launch template, yes. So that's I think that's one of the things that I actually missed to show you. I can quickly show you that. So if you look at the launch template itself, when I deployed.
Sorry, just actually your screen again. I stopped briefly for the Q&A. Sorry.
Oh, okay, cool. No worries. Okay, I'll just do it. Can you see it now?
Yeah.
Okay, cool. Yeah. So from a launch template perspective, so I did configure that on my Terraform code to go and deploy that. So if you go under details, right? I think I didn't show you that. If you go under details, I think it's going to be under here. So there's that instance profile, the one that I mentioned. And if I go to the EC2 instance, for instance, I'll go to the EC2 instance. Let's just go to the EC2 instance. Okay, there's the EC2 instance. Then you go under security. What happened there? Okay, there's the EC2 instance. Under security, there's that role, right? This is the role, that instance profile. This is this role here. And this role here, if we go to that role, you will see it will be under IAM. So what I configured on that launch template is just the basics. You can do more than that. You can specify whatever that you want on the launch template of for your auto scaling group. So these are the policies like I showed you from Terraform to say it's gonna add these policies for RDS. That's for your S3 and so on. Once the instance is deployed, then it's going to look at that launch template, right? Using that role, that EC2.
Wow, mid load shedding. I think we just lost them, but somehow we got an image of the power going out before his internet died. Sure. What's the chances of that? While we wait for Josh, what was it me? You guys can hear me, right? Just
Yes, we can hear you.
Okay, so it was not me. Let's just maybe complete the questions and see when it comes back. I don't think there's a lot remaining. Like one of the other questions was, could it be possible to do the entire demo using the AWS CLI? And yes, it can definitely be done using the AWS CLI, but then you would have to execute so many commands after each other, like take the previous command output, put it in this one. So it's just much easier to use some infrastructure as code tool, either CloudFormation or Terraform or the AWS CDK, or you can also use Pulumi, like that's also a very popular one. So like those four are just like the standards if you like really deploy hardcore AWS stuff. What's a stress test? That's just the program that he was planning on using to simulate some CPU work so that we can see how those instances scale out and scale in. But we actually clicked on it enough for that CPU to go up and down.